Far in the future, after galaxies fade and stars burn out, the universe will approach a silent and empty state. But even then, something may remain. The question is not just how the universe ends, but what becomes the last thing left within it. What survives when everything else disappears? The universe began with immense energy and structure, forming galaxies, stars, and planets. Over time, these structures evolve and eventually decay. Every star has a lifespan, and every system slowly moves toward its end. As stars exhaust their fuel, they collapse or fade into remnants like white dwarfs, neutron stars, or black holes. Over trillions of years, no new stars will form, leaving the universe darker and quieter. Galaxies themselves will lose structure, stars drift apart, and gravitational interactions weaken. Eventually, galaxies become sparse collections of remnants moving through expanding space. Black holes will dominate this late universe. Formed from collapsed stars and galactic centers, they will absorb surrounding matter and become the last major structures holding energy and mass. But even black holes are not eternal. Through Hawking radiation, they slowly evaporate, losing mass over extremely long timescales. This process is slow, but inevitable. When the last black hole evaporates, one of the final concentrated objects disappears. The universe is left with only scattered particles and low-energy radiation. At this stage, matter becomes extremely rare. Particles drift vast distances without interaction. The universe becomes almost completely empty. Some theories suggest that protons may decay. If this occurs, even the basic building blocks of matter will not last forever. Over immense time, matter could dissolve completely. If particles continue to decay, the universe may be left with only photons and other simple forms of energy. These particles spread across expanding space, becoming increasingly diluted. The last thing left may not be matter at all, but energy, faint radiation drifting endlessly, with no structure or interaction. Representing the final trace of the universe's past, quantum fluctuations might still occur. Even in near-empty space, these rare events could briefly create particles, but they would disappear almost immediately. Time in this state becomes difficult to define. With no events or interactions, there is nothing to measure change. The universe exists in a state of near-complete stillness. The concept of last becomes unclear. If nothing changes, the universe may continue indefinitely, frozen in this minimal state. The final remnant of the universe may be something incredibly simple: a single particle, a faint photon, or even just empty space itself. The last thing left in the universe is not a grand object, but a quiet reminder of everything that once existed, a final trace of a cosmos that was once filled with light, structure, and life, now reduced to near nothingness.